All right, section 2.6, transforming linear functions. We did transforming back in 1.8, and we transformed by graphing and doing each point. Today we're going to be transforming by using function notation. So function notation is f of x equals an equation. Okay, we're just going to use the function. We're going to do a little bit of graphing, but mainly the function. Okay, here's your 4 rules. I need you to push pause and write them down, very detailed. You're going to use these all the time. First, a vertical shift of k units. We are just doing linear functions, just lines, no quadratic, cubic, whatever. So your rule, your function changes to your function plus k. Okay, k, once you're given a problem, like a vertical shift of k units, you take the absolute value of that and plug it into your rule. Now, if k is greater than 0, if the k you're given is positive, your function moves up. If it's negative, it moves down. Horizontal shift of h units, absolute value h. You're going to be given a problem, it'll be plus or minus. When you plug it into this formula, you take the absolute value of it. Take away the negative if it's negative. So your function changes to your function x minus h in parentheses. If the problem as it's given to you is greater than 0, your line moves to the right. If it's less than 0, your line moves to the left. Reflection across the y-axis. Okay, you just change your function to negative x in parentheses. Reflection across the x-axis, change it to f of x goes to negative f of x outside of the parentheses. Remember the difference between vertical and horizontal translations. Add to y, go high. Add to x, go left. Just little things to try to remind you what to do. Okay, here's our first example, translating and reflecting functions. Okay, read this slowly. Let g of x be the indicated transformation of f of x. Write the rule for g of x. So we're given a problem, a function, it's labeled f of x. We're going to transform that function and relabel it g of x. All right? So the problem is f of x equals x minus 2. You need to perform a horizontal translation, write 3 units. So I've copied the chart that needs to be in your notes right here, and this is what we're doing. So we're doing, our new function is going to be labeled g of x. We're doing f of x minus 3 in parentheses. Okay, so now you write down your function, and where you see x, you write x minus 3 minus 2. Simplify it. X minus 5. Okay? Let me refresh your memory. If you ever had a function f of x equals x minus 2, and I told you to evaluate f of 3, you would take that 3 and replace it. Okay? Same deal here. I'm telling you to evaluate your original function at x minus 3. So where you see x, you replace it with x minus 3. And then simplify. Same deal as like this. Okay, next example, translating and reflecting functions. Same instructions. Let g of x be the indicated transformation of f of x. Write a rule for g of x. Our problem doesn't give us an equation this time. We have a linear function defined in the table, and we want to reflect it across the x-axis. Note, you need to write a function in slope-intercept form from the data. So first, slope-intercept form. I need to figure out the slope, just like we did last section. I'm going to grab these 2 points. Okay, change in y, or change in f of x, over change in x. And stay consistent in what order? 2 minus 1 over 2 minus 0. Gives me 1/2. At this point, I'm going to remind you the definition of y-intercept. Okay, that's your b. The y-intercept is your y value where x equals 0. And if you look here in the table, x equals 0, f of x equals 1. So your y-intercept is 1. So your equation is f of x equals m x plus b. Okay, go to the next slide and write that down. So again, I copied this over here for you, and this is what we're going to do. Okay, our new function, which we're going to name g of x, is negative f of x. So that means I'm going to take negative and write down f of x. And if I have a negative outside parentheses, I distribute that negative everywhere inside the parentheses. And we have our new rule. Okay, you try. Let g of x be the indicated transformation of f of x. Write the rule for g of x. F of x equals 3x plus 1, and we're translating it 2 units right. And I've copied the rule here. Push pause and go ahead and try it. Okay, there you go. Push pause and look at that and move on to the next slide. Alright, here you go. Let g of x be the indicated transformation of f of x. Write the rule for g of x. We have a linear function defined in the table and a reflection across the x-axis. Push pause and go ahead and work on it. Alright, and there you go. I found the slope. I found the y-intercept, which is where x equals 0, so that was easy. And I wrote my f of x function. I know that the rule from the charts is g of x is negative f of x. So I did g of x as negative, the entire function, distributed my negative, and I have an answer. Alright, stretches and compressions. Change the slope of a linear function. If the line becomes steeper, the function has been stretched vertically or compressed horizontally. If the line becomes flatter, the function has been compressed vertically or stretched horizontally. Write that down. Here's your chart. Okay, copy it. We're going to use it. Horizontal stretch or compression by a factor of b. Okay, that means that we multiply 1 over b times x in our function. Vertical stretch or compression by a factor of a. That means we multiply a outside of the function. If b is greater than 1, we're stretching away from the y-axis. If b is a fraction, if it's between 0 and 1, we're compressing towards the y-axis. If a is greater than 1, we're stretching away from the x-axis. If a is a fraction, or between 0 and 1, we're compressing towards the x-axis. Helpful hint, these don't change. The y-intercepts in a horizontal stretch or compression will not change. The x-intercepts in a vertical stretch or compression will not change. Alright, let's try this one. Let g of x be a horizontal compression of f of x equals negative x plus 4 by a factor of 1/2. Write the rule for g of x and graph the function. Okay, b is 1/2. Our rule right here says that we're going to go, our new function equals f of 1 over b x. So what is 1 over b? 1 over b is 1 over 1/2. So that's 1 divided by 1/2, which is 1 divided by 1/2. Division of a fraction is the same as multiplication of the reciprocal. So 1 over b is 2. So g of x equals negative 1 over b x plus 4. Simplify. G of x equals negative 2x plus 4. That's your answer. Now we're going to graph them on the next page. Alright, the orange one, the f of x. Y-intercept is 4, 1, 2, 3, 4. Dot. Slope is negative 1 over 1. So negative 1, positive 1, negative 1, positive 1, or positive 1, negative 1, positive 1, negative 1. Draw your straight line with your straight edge. And g of x. Slope or the y-intercept is also 4. And my slope is negative 2, positive 1, negative 2, positive 1, negative 2, positive 1, or positive 2, negative 1. Okay, you wrote down in your notes earlier, if the line becomes steeper, the function has been stretched vertically or compressed horizontally. You also see in the chart that you wrote down, if b is a fraction, if it's between 0 and 1, we're compressing towards the y-axis. So this did compress towards the y-axis. Okay, you try this one, stretching and compressing linear functions. Let g of x be a vertical compression of f of x equals 3x plus 2 by a factor of 1/4. Okay, vertical compression, your function, factor of a fourth. Write a rule for g of x, and I've copied down your rule here. Okay, so we have a equals 1/4. Push pause and try on your own first. All right, here's the work. G of x equals a times f of x. A is 1/4. G of x equals 1/4 times 3x plus 2. Distribute your 1/4, multiply it. G of x equals 3/4 x plus 2/4. I did 1/4 times 3, got 3/4. 1/4 times 2, got 2/4. Simplify. There's my actual answer. Okay, we need to graph it on the next page. Okay, here you go. F of x is in orange. G of x is in blue. Notice for g of x, I have a y-intercept of 1/2. So when I do my slope, I'm going up 3 and right 4 on the halves. Okay, then I went down 3 and left 4 on the halves. You wrote down earlier, if a line becomes steeper, the function has been stretched vertically or compressed horizontally. If the line becomes flatter, which is this case, the function has been compressed vertically or stretched horizontally. You also have written down in your chart vertical stretch or compression by a factor of a. If a is a fraction, it compresses towards the x-axis, which is here. We got closer to the x-axis. Okay, let's roll what we've done into a double-step transformation. Some linear functions involve more than one transformation by applying individual transformations one at a time in the order which they are given. For multiple transformations, create a temporary function such as h of x to represent the first transformation, then transform it to find combined transformations. So we're going to be given a problem. First step, we're going to h of x. Second step, we're going to g of x. G of x will be our answer. All right, let's try one. Let g of x be a horizontal shift of f of x equals 3x left 6 units, followed by a horizontal stretch by a factor of 4. Okay, I've got both rules written here. Horizontal shift and horizontal stretch. With this first one, we're going left 6 units, so h equals -6 because we're moving left. Horizontal stretch by a factor of 4, b equals 4. So our temporary function, h of x, equals f of x minus a -6. So h of x equals f of x plus 6. So let's do the actual problem. Equals 3 times x plus 6. That means wherever we see the x in our problem, we're putting in x plus 6. H of x equals 3x plus 18. Okay, that was our temporary, so let's go to our next one. We're doing g of x. G of x equals so stretching h of x horizontally by a factor of 4 replaces each x with 1 over bx. And we just said b equals 4. That's what I did here. Okay, so g of x is going to be h of x, and where you see x, you're replacing it with 1 over b. So g of x equals 3 times 1 over 4x plus 18. So g of x equals 3/4 x plus 18. And you have your final answer. It's really important for you to show all your work here because half credit, you get it if you get half of it right. I mean, it's 2 steps, so if you miss one step, you'll still get a lot of points. If you miss both steps or if you don't show your work, I'm not sure what to do. Okay, our first problem, you're going to try it. I know it's going to be difficult, but you guys are super smart, so try it on your own and look at the answer. Let g of x be a vertical compression of f of x equals x by a factor of 1/2, followed by a horizontal shift left 8 units. Write the rule for g of x. So first, you're doing a vertical compression. A equals 1/2. Next, you're doing a horizontal shift left 8 units, so h equals -8. So try it on your own first. Remember, we're doing h of x, that's our middle one, and then g of x. Do your best. All right, first I went h of x equals a times f of x. A is 1/2. So h of x equals 1/2 x because our function is pretty simple. Then we went to g of x, the final step. G of x is, oh, there's a typo. This should be h of x minus a negative 8. So g of x is h of x plus 8. So we plug that into our h of x, 1/2, and where you see an x, you write in x plus h. Distribute your 1/2 and you have your final answer.